Imagine you're looking up at the night sky and you see Orion, the hunter. And in Orion's sword, there's this kind of like faint, fuzzy patch. You might just think it's a star. But it's not a star, is it? It's a stellar nursery. It's called the Orion Nebula. And stars are actually bursting into life there, like right now as we speak.
Yeah.
And it's 1,344 light years away.
Yeah.
But we can still see it.
We can.
So today, we're going to dive deep into this stellar nursery.
Awesome.
And we'll be using all the latest insights from incredible telescopes like the James Webb, trying to unravel all the secrets this nebula holds.
Yeah.
Welcome to Cosmos in a Pod Space and Astronomy series. So I'm really curious about what's actually inside this nebula. What's it like?
Well, imagine like all these vibrant colors, right? Kind of like dancing across this canvas of swirling gas and dust. And these colors are all different. There's red and purple from glowing hydrogen. Then there's green from oxygen and blue from scattered starlight. That's what the Orion Nebula is like a giant cloud spanning 23 light years across. Yeah, and teeming with over 3,000 stars.
Oh, wow.
And they're all in different stages of development, but it's not just, a cloud. It's part of something even bigger called the Orion Molecular Cloud.
Oh.
Which includes things like the Horsehead Nebula and Barnard's Loop. We can dive into those a little later, but for now, let's stick with the Orion Nebula.
That's amazing. 23 light years. That's hard to imagine.
It is.
All those colors. It sounds kind of like a cosmic fireworks display,
Kind of.
But this nebula isn't just a pretty sight. It's a place where stuff is happening all the time.
Right.
A lot of activity.
Lots of activity. Yeah, it's like a giant cosmic construction site.
Oh, wow.
And stars are constantly being born there. Deep within the heart of this nebula, there is a cluster of stars called the Trapezium Cluster.
Okay, so let's go there. Let's journey right into the heart of this stellar nursery.
Yeah.
What makes this Trapezium Cluster so special?
Well, this cluster is dominated by 4 massive stars, way bigger, way hotter than our sun. And these stars are young, so young, and they're bursting with energy.
Yeah.
The most luminous one is called Theta 1 Orionis C, and it has a surface temperature of 45,500 Kelvin.
45,000 Kelvin. What does that even mean?
So, for context, that's 8 times the radius of our sun.
Wow.
And 250,000 times brighter.
That's unbelievable. Imagine being on a planet orbiting that star.
I know.
Wow. So are these massive stars just putting on a light show for us? Or are they actually doing something more?
Oh, they're definitely shaping their environment. So these hot young stars emit powerful stellar winds.
Okay.
And these are like streams of charged particles blasting outward. And they sculpt the surrounding gas and dust. They clear out cavities. And they expose new regions, and more stars can form there. It's this delicate balance between creation and destruction.
It's like they're architects, but they're also the demolition crew.
Yeah.
Right. What a crazy dynamic. I've heard that the James Webb Telescope has shown us some incredible things about the Orion Nebula.
Oh, it has, yeah. You're right. James Webb has this amazing infrared vision, and it can see right through dense clouds of gas and dust, showing us things that we could never see before. It's like it can see through a wall.
Really?
Yeah.
So what has it shown us?
One of the most exciting discoveries is the observation of protoplanetary disks, or proplyds. Proplyds?
What are those?
These are cosmic nurseries. Disks of gas and dust swirling around young stars.
Okay.
And they're the raw materials that form planets, moons, and asteroids. There's one example, Orion 294661, a young star surrounded by a proplyd that's 300 times wider than the distance between Earth and the Sun.
Wow. That's massive.
It's massive.
So we're actually seeing planets being made right now.
We are. It's like watching the universe build itself.
That is mind-blowing.
Yeah.
It really is.
Yeah.
It makes you realize that the universe is so vast and active, constantly creating and evolving. But I'm also really curious about these spectacular jets of gas you talked about before.
Oh, yeah. Those are called Herbig-Haro objects, and they are incredible. Just imagine these glowing jets of gas shooting out from baby stars, like cosmic lasers, at unbelievable speeds.
Wow.
And those jets, they slam into the surrounding material, creating shock waves, and then they glow so brightly in infrared light.
So, like a cosmic light show.
Right.
But is there a deeper purpose?
There is, yeah. These Herbig-Haro objects, they regulate star formation.
Really?
They disperse the surrounding gas and dust, and that can trigger the formation of even more stars.
Wow. It's incredible how much is happening within this one nebula. It's like a never-ending cycle of creation and
Yeah,
change.
it really is. But we've only just scratched the surface here.
Right.
There's still so much more to discover about the Orion Nebula, from mysterious bullets hurtling through the cloud to the complex forces that shape its evolution.
There really is. This has been incredible so far. We've only just begun to explore this incredible stellar nursery. So, what other wonders await us in this vast cosmic cloud? Join us for part 2 of this deep dive into the Orion Nebula, where we'll continue our exploration of this stellar wonderland.
Welcome back to our cosmic exploration.
It really is amazing to think that we've only just begun to explore this stellar nursery.
Right.
It's incredible. So what else is out there? What other wonders await us in this cosmic cloud?
Well, we've been talking about the Orion Nebula itself, but remember, it's just a small part of a much, much larger structure, the Orion Molecular Cloud.
Right. You mentioned that earlier. Just how big is this cloud, though?
It's huge. It stretches for hundreds of light years, encompassing almost the entire constellation of Orion. It's a vast sea of gas and dust where stars are born and where spectacular nebulae like the one we're exploring, they take shape.
So it's like the Orion Nebula is just the tip of the iceberg.
Exactly. And within this enormous cloud, there are all sorts of fascinating objects. One of the most iconic is the Horsehead Nebula.
Oh, yeah?
You've probably seen pictures of it.
I have.
It's a dark, shadowy shape.
Resembling a horse's head silhouetted against a bright reddish background.
Yeah, it's pretty amazing.
It's a really striking image.
So what makes it look like that? Why is it shaped like that?
It's a dense cloud of dust that's blocking the light from the glowing nebula behind it.
Oh.
It's about 3.5 light years across, and it's a testament to the power of interstellar dust to absorb and scatter light. It's like a cosmic shadow play,
Wow.
revealing the hidden structures within the cloud.
So these clouds of gas and dust, they can really create some intricate and beautiful shapes.
They can. Yeah, it's amazing.
Oh, what about Barnard's Loop? You mentioned that before.
Ah, yes. Barnard's Loop. Imagine a giant glowing arc stretching across 300 light years of space.
Wow.
That's Barnard's Loop. It's thought to have been formed by a series of supernova explosions millions of years ago.
Supernova explosions, those are the ones that happen when massive stars die.
Yes, exactly. And these explosions, they release tremendous amounts of energy, right?
Yeah.
And they send shock waves through the surrounding interstellar medium.
Mm.
Barnard's Loop is like the glowing remnant of those shock waves,
Oh, wow.
a testament to the power of stellar death.
It's kind of incredible to think that the death of stars can create something so beautiful and vast.
It really is. It's a powerful illustration of the cosmic cycle of creation and destruction. So the elements that are forged in the hearts of stars, right? They're scattered throughout space when those stars die. And then those elements, they become the building blocks for new stars, planets, and even life itself.
So it's like a giant cosmic recycling program.
Exactly. The death of one generation of stars provides the seeds for the next. And that brings us back to the Orion Nebula. As awe-inspiring as it is, we have to remember that it, too, is a fleeting beauty.
Wait, are you telling me that the Orion Nebula will eventually disappear?
It's true. The intense radiation and stellar winds from those hot young stars, they're gradually pushing the gas and dust outwards. They're dispersing the nebula.
So it's like the stars are blowing away their own nursery. In a way, yeah, they are. Astronomers estimate that in about 100,000 years, the Orion Nebula will have dispersed completely, leaving behind a loose cluster of stars.
Oh, wow.
Much like the Pleiades.
100,000 years sounds like a long time. But on a cosmic timescale, that's just a blink of an eye, right?
Yeah.
It makes you realize how precious and fleeting these cosmic wonders really are.
It does. It highlights the importance of appreciating these celestial objects while we can. They remind us that everything in the universe is in constant flux, constantly changing and evolving.
That is a humbling thought. So you said the Orion Nebula will leave behind a cluster of stars. What happens to those stars once the nebula is gone?
They'll continue to orbit the center of the Milky Way galaxy, just drifting apart over millions of years. Some will live long, peaceful lives, slowly burning their fuel. Others, the more massive ones, they'll meet more dramatic ends, exploding as supernovae, and then seeding the interstellar medium with the elements for new generations of stars.
It's amazing how interconnected everything is in the universe.
It really is.
The death of one star leads to the birth of countless others. This amazing cosmic dance of energy and matter.
It is a fascinating cycle, one that we're still learning about.
Yeah.
And the Orion Nebula, with its vibrant display of star birth and evolution, it's one of the best places to observe this cosmic ballet.
That's pretty amazing. This has been an incredible journey so far. We've explored the heart of the Orion Nebula. We've learned about its place in the larger Orion molecular cloud, and we've even contemplated its eventual fate. But it feels like there's even more to this story.
You're right, there is. We've talked about the beauty of the Orion Nebula and its role in the cosmic cycle. But there's another fascinating aspect to explore, and that's the mysteries that still linger within this celestial cloud.
Mysteries? What kind of mysteries?
Well, for all that we've learned, there are still questions that puzzle astronomers. Remember those bullets we mentioned earlier, those dense clumps of gas hurtling through the nebula at incredible speeds?
Yeah, those are pretty strange.
We still don't fully understand their origin. What triggered these high-speed projectiles? Was it a stellar collision? A supernova explosion? We're still piecing together the clues.
So it's like a cosmic detective story.
It is.
And what about those Herbig-Haro objects?
Yeah.
The jets of gas shooting out from baby stars.
Yeah.
Do we have all the answers about those yet?
Not quite. While we've made great strides in understanding these jets, there are still questions about how they are collimated and focused so precisely. How do these baby stars manage to create these powerful, narrow beams of gas? It's a challenge to our current models of star formation.
So even with our advanced telescopes and theories, the Orion Nebula still holds secrets.
It does. It's a reminder that the universe is full of wonder and mystery. Even in the most well-studied regions of space, there are still surprises waiting to be discovered.
It's pretty exciting to think about all the new discoveries that await us, especially with the James Webb Space Telescope now in operation. What kind of breakthroughs do you think we might see in the coming years?
Well, the James Webb Space Telescope, it's already revolutionizing our understanding of the Orion Nebula. Its infrared vision is allowing us to see deeper into the cloud, revealing the earliest stages of star and planet formation in unprecedented detail. We're likely to see discoveries related to protoplanetary disks, the formation of giant planets, and the complex chemistry of the interstellar medium. It's a thrilling time to be an astronomer.
It sounds like we're on the verge of a golden age of Orion Nebula research. But before we get too far ahead of ourselves, let's take a step back and reflect on what we've learned so far.
That's a good idea. We've covered a lot of ground. We've journeyed from the heart of the Orion Nebula to its place in the vast Orion molecular cloud. We've explored its stunning beauty, its role as a stellar nursery, and its eventual fate. We've even delved into some of the mysteries that still linger within this cosmic cloud.
It's been an incredible journey. I feel like I have a much deeper appreciation for the Orion Nebula now. But I know we have one more part to this deep dive. What awaits us in the final chapter of our exploration?
Well, in our final part, we'll zoom out even further, contemplating the grand cycle of star birth and death that plays out on a cosmic scale. We'll consider the profound impact the Orion Nebula has had on our understanding of the universe and explore the philosophical implications of this fleeting celestial wonder.
It sounds like a fitting conclusion to our journey. I can't wait to explore these grander themes and contemplate the deeper meaning of the Orion Nebula. Join us for the final part of our deep dives as we wrap up our exploration of this cosmic masterpiece. So we've journeyed to the heart of the Orion Nebula.
Yeah.
We've seen its turbulent beauty, and we've even uncovered some of its secrets.
Right.
Now I'm kind of ready to take a step back and think about the bigger picture.
I think that's a perfect way to wrap up our exploration. The Orion Nebula, for all its grandeur, is really just one small stage in a much grander cosmic play. The cycle of star birth and death that unfolds across the entire universe.
Yeah, it's a cycle that the Orion Nebula embodies perfectly, wouldn't you say?
Absolutely. Within this one nebula, we can see stars bursting into life,
Right.
while others are reaching the end of their journey, and then their deaths enrich the interstellar medium with elements for new generations of stars.
It's
So
incredible.
it's a continuous dance of creation and destruction, energy and matter, playing out on a timescale that dwarfs our human comprehension.
Yeah, earlier you mentioned that the Orion Nebula itself is destined to fade away. It's a kind of sobering thought considering how breathtaking it is.
It is, but it's also a profound reminder that nothing lasts forever, even on a cosmic scale. The nebula, as we see it today, is just a fleeting moment in time.
Wow.
Eventually, those powerful stellar winds and radiation, they'll disperse the gas and dust, leaving behind a loose cluster of stars.
So the stars that are born within the nebula will eventually drift apart.
Exactly. They'll drift apart over millions and billions of years, each embarking on its own unique stellar evolution. Some will live long, relatively quiet lives, slowly burning their nuclear fuel. Others, the more massive ones, will burn bright and fast, ending their lives in those spectacular supernova explosions. And those explosions then seed the interstellar medium with the elements for new stars and planets.
It's just incredible to think that the death of one star can give rise to countless others,
Yeah.
continuing the cycle of cosmic creation.
It's a beautiful and humbling thought.
Yeah.
And it highlights how interconnected everything is in the universe. We are, in a very real sense, stardust, forged in the hearts of long-dead stars.
That is a profound realization. It connects us to this vast cosmic web of energy and matter. But beyond its philosophical implications, the Orion Nebula has also played a crucial role in advancing our scientific understanding of the universe.
Absolutely. It's been a testing ground for our theories of star formation, a cosmic laboratory where we can actually observe these processes in action and refine our models. By studying the Orion Nebula, we've learned about the composition of interstellar gas and dust, the dynamics of stellar winds, and the complex interplay between gravity, radiation, and magnetic fields.
It's amazing to think that this distant object can teach us so much about the fundamental laws that govern the universe.
It is, and with new instruments like the James Webb Space Telescope, we're going to make even more groundbreaking discoveries in the years to come. Who knows what secrets the Orion Nebula still holds, waiting to be unveiled?
It is an exciting time to be exploring the cosmos. But as we conclude our deep dive into the Orion Nebula, I can't help but feel a sense of awe at the sheer scale and beauty of the universe.
I feel it too. The Orion Nebula, with its vibrant tapestry of gas, dust, and stars, is a reminder that the universe is a place of constant change, a place where beauty arises from chaos and where the end of one cycle marks the beginning of another.
It's a perspective that shifts our focus from the everyday worries of our lives to this grand cosmic narrative of which we are all a part.
Absolutely. And if this deep dive has sparked your curiosity about the cosmos, we encourage you to continue exploring, learning, and asking questions. There's a whole universe out there waiting to be discovered.
Well said. For those of you who want to continue your cosmic journey with us, be sure to follow Cosmos in a Pod and subscribe to our YouTube channel for more deep dives into the wonders of space and astronomy. Until next time, keep looking up and never stop exploring the vast and mysterious universe that surrounds us.